All right, here we go. 6.3 is all about logarithms and logarithm functions. So hopefully this video will help things. Number 1 says rewrite each equation in exponential form. So remember, this is from that big chart that we've been doing in class. Okay, the base stays the base. The answer becomes the exponent, and what you were taking the log of is your new answer. Okay, I like to teach it like this. You guys are all about that apparently, okay? It goes base, answer, exponent. Okay, that's just kind of how I like to view things. So here on B, the base of our logarithm, it stays as our base. The answer becomes your exponent, and what you were taking the logarithm of is now your new answer. Okay, it should also make sense. This should not be an x, that should be a 3, because that was our answer. Great. Okay. So from here, it should make sense. If you type into your calculator that 6 to the third is 216, it should make sense. It should match, okay? Over here, if you do 1/5 to the negative 1, it should be 5. Okay, so always check your work on that because you get 100%. That's awesome. All right, rewrite each in logarithm form. So we're going backwards now, okay? So we've got the log of our base is our base now. So the log base 9 of, okay, basically we're going to take that. That's going to become our new answer. We're taking the log of 81, and that's equal to 2. Okay, so we just kind of flip-flop those two things. Over here on B, works the same way. We've got the log base, well, the base is 15 of, we're going to take our answer, and that's equal to negative 2. Okay, at this point, just memorize the process. Okay, I know that logarithms are still a little bit weird, and you don't really know what they are. Just memorize the process, and I think as we do a little bit more of this, you're going to understand it. Okay, all right, number 3, it says evaluate each logarithm. Okay, so first of all, let's change it to exponentials because you understand exponentials better than logarithms anyway. So our base stays the base. Okay, think of it as equaling to x, and we have to figure out what x is. All right, the answer becomes the exponent, and then we've got 256. Okay, so now what we have to do, we have to figure out 4 to what power is 256. I like to do guess and check. Let's do 4 to the third. That's 64. That's not quite big enough. What about 4 to the fourth? Oh, that gets us there. Great. So x must equal 4. Okay. On B, the log base 1/3 equals 27. So that means that 1/3, okay, if we're thinking of this equaling to x, to some power is equal to 27. Okay, well, hopefully by now you realize that 3 to the third would get you to 27, right? But it's 1/3 to some power. So let's try this. 1/3 to the third, that's definitely not it. Okay, but here's the thing. If you turn this to a fraction, you're going to get 1 over 27. And that's the reciprocal of what we really want. And remember, if we're dealing with reciprocals, then that means that we have a negative exponent somewhere. So what if we tried 1/3 to the negative first? Oh, looky there. We get 3. Okay, so then if we do 1/3 to the negative 3, that gets us to 27. Okay, so kind of use a little bit of logic there. Okay, so x has to be negative 3. On C, if we were to think of it as equaling to x, 64 to the x power is 8. Now, a lot of you are going to be tempted to say 2, but watch what happens. If we do 64 squared, we get a way bigger number, okay? That's because 8 squared gets us to 64, so we need to go backwards. And if you remember, the opposite of squaring is square rooting, right? The square root of 64 is 8. So we need to express the exponent as a square root, and hopefully you remember either from class or your brain that when you square root something, that's like taking it to the power of 1 over 2. And if you don't know that, you can always plug it into your calculator and check your work. Okay? If you're having issues with that, come see me in class and I'll help you out, okay? All right, number 4. Simplify the following. This is one of those special cases where if you remember in class, when you just see the logarithm with no base, the base is 10. Okay, so here what we're dealing with is a base of an exponent that's the same of the base of the logarithm in the exponent. And if you remember, that just canceled. And so all you're left with is 18. Okay, that's just something you got to memorize. Over here, it's similar, but a little bit more work is involved. Here, we've got the log base 4, and things would cancel if this base was 4, but it's not at 16. However, you could write it as 4 squared, right? Because 4 squared is 16, so we haven't really changed anything about it, right? And then those exponent rules tell us that it's kind of like that, because all you have to do is multiply the exponents, okay? And now we can cancel that because the bases are the same, and all you are left with is the exponent. Okay, just memorize that process and makes your life way easier, I promise. All right. Now on number 5, you will have problems like this on your quiz. You will have them like it on your test. I highly suggest that you practice this a whole lot. Okay. 5a says find the inverse of each. Okay, if you remember, the inverse of an exponential is a logarithm. Okay, so if we've got y equals 2 to the power of x, okay, if you remembered that an exponential is the inverse of a logarithm, then all you have to do is change this to be the logarithm. So the log base 2, because the bases are the same, okay, of x is equal to y, okay? So here's how this works. When you're thinking about an inverse, remember you have to switch the x and the y first. Okay, that's what the idea of an inverse. And then you change that to the logarithm form. So the base stays the base. Okay, the answer is what you're taking the logarithm of, and the exponent is your new answer. Okay, hopefully that helped a little bit. Let's do B. Maybe it'll help again. All right, so let's switch our x and our y's here. So there we are. Now, the opposite of a logarithm is an exponent, okay? So let's do this. The base here is 10, right? So let's make the base of our exponent 10, and then we can just put everything that we had into the exponent like that, okay? Here's how this is helpful. This side stays the same, but those cancel, right? Because the base and the base are the same. So then all you're left with is y minus 3. And why this is helpful is if you remember correctly, an equation looks like y equals. So if we can just make this say y equals, we're done. Well, we can just by adding 3. Okay, so we've got 10 to the power x plus 3 equals y. And that is your final answer. Okay, so if I were to summarize this, I would say the first step is to switch the x and y. And then step 2 is to use the inverse. So like here, we had an exponential, so we used a logarithm. Here we had an exponential or a logarithm, so we used an exponential. Okay. And 3, we need to solve. I cannot spell today. We need to solve for y. Okay, so I don't know if you need to like write that in your notes or something. Hopefully you have something similar, but hopefully that helped. Really, really study number 5. That seems to be an issue with a lot of kids every single year. So study that. Hopefully it helped. If not, come see me.